Hey, chemistry students, this is Mr. Rotzenberg, and I'm going to quickly go over the answer key to the lab that you did last week, the Trends E-Lab. As you can see in front of me is question number 1. This was just typing in the numbers. Really nothing I have to go over there. That was out of 1 point. Question 2, and then also question 4 is where students started to struggle. So again, as you go down a group on the periodic table, the atomic radius will increase is the first space. And this is due to gaining another shell of electrons as you go down. Recall on your periodic table that we had you draw out on, as you go down the periodic table, you gain another shell of electrons. Now, question number 3 with the table, again, going across, fairly straightforward there. Question number 4, this is the trend that students struggle with. As you go left to right, atomic radius actually decreases a little bit. You can see that of the numbers that I have on the top of the screen right now. The reason why is because as you go left to right across your periodic table, so again, look at sodium with 11, magnesium with 12, then I move over here, you have aluminum with 13, so on and so forth. You gain more protons. Those protons attract the same number of electron shells to bring them in a little bit closer. Again, a very common question that students got partial credit on because they weren't sure. Number 5, ionization energy. As you look at those numbers there, they go down as you go down the periodic table. And why? Well, as you look at this student, what they said was as you go down a group, there are more electron shells. Again, remember what we talked about before. The more shells there are, the greater the atomic radius and the lesser the attraction. Now, I would have loved this student would have said lesser the attraction between the nucleus and the outermost electrons, but they still receive full credit for this. This means that it's easier for electrons to be removed, and there's a smaller ionization energy. Now, a couple things I want to go over with number 7. The first thing is the general trend is ionization energy is increasing as you go left to right. Again, as you look at these numbers, they increase. Now, I'm going to talk about this arsenic selenium little dip before it goes back to increasing here in a minute. But first, let's address question number 8. That again, as you go across the period, ionization energy is generally increasing because there are more protons in the nucleus. That means there's a higher attraction to those outer electrons, so it's harder to remove them. So that's what we want you to get out of this, is that, again, smaller atoms hold onto their electrons tighter. So it's going to be a high ionization energy. Bigger atoms don't have as good of an attraction towards those outer electrons, so it's a lower ionization energy. Now, some students have asked about that discrepancy. Now, I'm going to show you a different set of data here. Here's silicone, then phosphorus, look at an increase, then sulfur, there's a slight decrease. After sulfur, there's chlorine where it would be an increase again. I just not add the chlorine. This goes a little bit beyond what you need to know for this class, but some students have been asking about this, so we want to respond. I've shown silicone, phosphorus, and sulfur with their orbital notations. Notice silicone has 2 electrons in the 3p and an open suborbital. Phosphorus, the next element, has 1 more electron to fill that suborbital. But once sulfur has to add a 4th electron in the 3p, there's more repulsion because I have 2 electrons in the same suborbital. That additional repulsion is going to make those electrons not be as tightly held by the nucleus. Therefore, the ionization energy drops a little bit. Now, as you add chlorine, you've already added that extra repulsion, so now you're just going to have more protons attracting things in again. But orbital notation explains why once we're filled, once we double up, then it gets a little bit easier to remove that electron before it starts getting harder again. Again, that goes beyond what you need to know for this course, but some students were asking about it, so I wanted to go over that with you. I would say the number one issue when it came to these trends was question number 10 and question number 12. Electronegativity is not the exact same thing as ionization energy, and some of you answered it as if it was. So first off, as you go down a group, electronegativity decreases. The reason being, atoms are getting larger. Again, you can see that in the answer in front of me. Leads to a higher atomic radius. If they're getting larger, that means the nucleus is not only having a hard time attracting its own electrons, but other electrons, the student writes down, or from a neighboring atom, because electronegativity is about taking from a neighboring atom. Some students bring up bonding pairs of electrons. They must be looking up stuff on their own, and we'll get into that later in this unit. But if you did not differentiate between attraction to your own electrons and attraction to other electrons, we can't give you full credit. So that holds true for number 10 and for number 12. Likely to attract other electrons because electronegativity increases as you go left to right across the periodic table. Now, questions 13 and 14 are very similar to what was on your breakout room on Thursday and Friday. We need you to know that metals will typically lose electrons because they have low ionization energy values. Remember, ionization energy is all about how easy is it to lose electrons. That's why we needed you to match up that trend with metals. And lastly, when you lose electrons, you are cations because cations are positive. Number 14, non-metals will gain electrons typically. This is because they have a high electronegativity. Remember what I just talked about, your nucleus trying to attract from another atom to grab those electrons. And if you have a negative charge, you are now an anion. The last answer, noble gases are not reactive because they have a full outer shell of electrons. They're not going to gain or lose electrons. So again, this student mentions they're not going to gain or lose. If you have a high ionization energy, that means it's going to be really tough for you to lose electrons. If you have a low or no electronegativity, that must mean then you are going to not be able to gain the electrons at that point. So hopefully that helps straighten out your questions when it comes to the lab. Let your teacher know if you have any other questions. Otherwise, we'll see you guys later.